So for our first full example here, I went ahead and pulled an example we've been working throughout the steps. This is the one that talks about atom bomb testing in Utah in 1955, and then what happened afterwards. So we went ahead in the beginning and made our list, and we've got those numbers there. We listed our hypothesis, having a greater than symbol because we want to show that the crew suffered a significantly higher rate of cancer. We found our test statistic, which was SE, and then Z as well. So the only steps we haven't done in this test are step 4 and step 5. Let's go ahead and start with step 4. So, to do step 4, that's my p-value. Remember, I always start by drawing my bell curve. The next thing I do after I draw my bell curve is I put my z-score on it. Because my z-score is positive, it's in the upper half. I am above what I would expect or assume would happen. So I'm going to put my z-score on there. Next, I'm going to shade. I shade depending on my alternative hypothesis. My alternative hypothesis is greater than, so I'm going to go ahead and shade above. Now that I've shaded above and got my z-score marked, the next thing I need to do is go ahead and go to my z-table for it. So let's go ahead and get a z-table in here. Remember that anytime I want to go ahead and find my p-value and I'm shaded above, I either am going to look at the negative z-score to find the lower end tail instead, or I'll have to take 1 minus whatever probability I find. This is because the z-table itself always gives me lower end probabilities. So when I look at 3.16 on here, it's actually going to give me this number, and so I'll have to convert it over to find the other. So I'm going to go ahead and look at 3.16, keeping it as is. When I do that, I'll trace 3.1 across, and I'll trace 0.06 down, and where they overlap there, that will be my probability. Now, in this case, it's important to realize that that probability right there is not my blue area. Rather, it's this lower green area, and that's because the z-table always gives me left end, or cumulative probabilities. So right here is 0.9992. If I want my blue area then, that's what side is shaded according to my alternative hypothesis, I'll go ahead and take 1 minus that to get 0.0008. So I've got a really, really tiny p-value in this example. Now let's go ahead and get rid of this z-table here so we can move on to our next step. Okay, now I've got my p-value, let's go ahead and talk about step 5, which is my conclusion. To reach my conclusion, I always compare my p-value to my significance level, and alpha of 0.05 is what we're always going to use in class. In this case, my p-value is 0.0008. That means there's like a 0.08% chance of that happening. That's a tiny chance, and the most important thing is it's less than a 5% chance. If my p-value is less than 0.05, then I will always reject H naught. That is, there is enough evidence to suggest, and here's where we customize it, in this problem, if we come all the way back up here again, the point of this problem was to show that the crew suffered a significantly higher rate of cancer than the public. So, when we come back down and state our conclusion, then there is enough evidence to show that. There's enough evidence to suggest the crew suffered significantly higher rates of cancer than the public. So this has been our first example of a full hypothesis test. We're going to run a ton more. Once again, every hypothesis test has 5 steps. We'll list, we'll state what we're trying to prove and what we're assuming, find the evidence, find the probability of all that with our p-value, and then reach our conclusion for our final step.